Hey, fancy a deep dive into Python and matrices with me? We're about to get all techy and explore something called an X matrix and check for it. So, an X matrix is like that one friend who only hangs out with the main crowd, the diagonal ones, and really doesn't zero-t mingle with the others of the diagonal. It's super cool for computations, and trust me, you'll get stuck into it soon. Alright, let's roll up our sleeves and start checking matrices to tell if they're the X-life of matrix types. You'll need a basic understanding of Python, loops, and some NumPy array action for this deep dive. We'll also chat about some Python performance tips, security touches, and real-world examples to get a taste of the big world out there. So, strap in, grab your coding gloves, and let's talk matrices and code. We are going to start by defining our X matrix checker function. First, create a function called is_x_matrix that will take one argument, a to-do list, which represents our matrix. Inside, we'll iterate through and check the non-diagonal elements and see if they're zero using a couple of double for loops. Here's some starter code. Python import numpy as np-definite is_x_matrix. If not matrix, return false. Rows is equal to lay. Calls is equal to lay. If rows is equal to calls, return false for I in range, for j in range. If I is equal to j and matrix is equal to 0, return false. Return true. Okay, got that? Now, let's test this out on a few matrices. Python's NumPy can really speed things up, but here's another version, a more Pythonic way that relies on NumPy tricks that are speed wizards in disguise. Python definite is_x_matrix_numpy, np_matrix is equal to np.array if np_matrix.shape is equal to np_matrix.shape, return false. If not np.al close, return false. Return true. The NumPy one uses broadcasting and matrix multiplication to keep it sleek and fast, while the first one shows how we check both the structure and element values. Feeling up for a speed challenge? Let's put these bad boys through their paces. Time to see them in action. Let's define some matrices, some X matrices, and some plain old A matrices. Python x_matrix_1 is equal to x_matrix_2 is equal to A_matrix_1 is equal to not_x_matrix is equal to. Now, let's put them to the test. Remember, the first one should ping true, and the others should wave it goodbye. Python print fancy a dash into some real-world applications? An X matrix, in a nutshell, is cool stuff to have when doing things like solving system of linear equations, eigenvalue problems, or even in graphics rendering techniques like computer vision. Now, imagine you are dealing with some heavy-duty computations in finance or physics, dealing with huge matrices representing these systems. Checking if a matrix is an X matrix could be a quick health check to skip irrelevant processing and speed up the simulation or modeling process. Security, you ask? It's all about being smart with how you handle large data efficiently and effectively. In financial computations, you can't afford miscalculations, and sometimes an X matrix can help optimize that. Remember, a little computational knowledge goes a long way in maintaining integrity, especially when automating tasks. Before we leave you to the wonderland of Python and matrices, make sure to give neeraj.qzz.io a click and subscribe to TechLab. Never stop learning, never stop coding. See you in the next techie adventure. Visit neeraj.qzz.io and subscribe to TechLab.